Okay, so here we are in the riser diagram and schedules, number 8. And so this is the step-by-step instructions we're going to be using to complete this panel schedule, sheet number 4, the luminaire schedule, the motor schedule, and the main distribution panel schedule. And then we'll have the single line riser diagram. There's some instructions there as well on how to fill that out after you draw all the little components of that. And again, you'll find all the schedules. They should be in D2L already. You've already downloaded those. Electrical 220 was one of the first assignments when you set up that drawing. So if you haven't done that step, or if you need to review the the changes that I might have made on some of the feedback that you received from that assignment, you might want to go and do that before you hand in the final projects. Make sure that all your calculations are done. So there's some calculations that we have to do for the panel schedule. So I'm just going to open that up here now as well. And those calculations, excuse me, those calculations just basically show us how to calculate the values in the panel schedule for the lighting panel schedule. So we're going to use 20 amp breakers. We already know that. That's the left side of the panel, and that's for circuits feeding lights. For the right side of the panel, we're using outlets, and those are going to be 15 amp breakers. Now the way that we're going to calculate the phase wattage, and we'll see where we calculate that, or where we put the value in, the way we're going to calculate it is 1440. Remember that number was, excuse me, came from 12 amps multiplied by 120 volts, and that was 1440 watts. That was the maximum that we could put on one circuit. So we're going to take the maximum number, or sorry, the maximum wattage divided by the maximum number per circuit and multiply by the actual number on the circuit. So really it's going to be 1440 divided by, we figured we could put 12 outlets on one circuit, right? Actually in certain situations, if it's an office it's 8, if it's a corridor it's 2, and if it's the warehouse it's 6. So we're going to do 1440 divided by the maximum, which is 8, times the actual number on that circuit. And that's going to give us our phase wattage. We're also going to be allowing for some spare circuits. So this is for the lighting panel. This is the first thing that we're going to do is the lighting panel. And we're going to be allowing one spare circuit for every 5 circuits used. Okay, round up to the nearest spare circuit. So if we use 12 circuits, we're going to be adding 3 spares. Okay, makes sense? And then we're going to be determining the current panel rating. So we'll get to that when we actually get down to that level. So let's go back to the instructions here. So the instructions really are step by step. The panel is divided into 2 halves. You guys knew that already. Left half of the panel is reserved for lights, and the right side is for convenience outlet receptacles. Just a little note that in industry it may not be the case. They might actually mix it up, but for the purposes of our assignment, we're keeping them separate. Left side for the lights, right side for the receptacles. The schedule not only shows the physical layout of the breakers, but also the phase that they're on. So we're going to be doing some calculations to determine how much each of those phases are loaded. So the first thing we're going to do, step number 2, is complete the header information of the panel schedule for the panel that we are using. So let's go into the schedule in AutoCAD, and this is the header right here. This section right here is the header. And we're going to complete the header information as much as we can at this point. So let me swap back here. We're going to input the voltage of the system, 120 over 208. So right under here under volts, that's what we're going to put there. Now I've created a couple text items here. This one is 250 millimeter high text, and this is 300 millimeter high text. For the most part, we're going to be using that 250 millimeter high text. So I'm just going to make a copy of it, and I'm going to paste it and just place it up in the top of the header here. And then I'll just change the text. So I'm just going to kind of place it as close as I can. It looks good. And so this is going to be 120 over 208. Okay, that's according to our instructions. All right, 120 over 208. Then we input the number of phases. So this is going to be 3 phase. So let me just make a copy of this. I want to try and keep everything lined up. So you notice I'm copying from using a base point of the line. That means that everything will be on the same line. So we have 3 phases. I've also got this text here justified to the middle center, I believe. Yeah, middle center, so it should be nice and centered as I copy it down. Make another copy. And the number of wires that we actually have 4 wires. Remember, we have 3 lives representing the 3 different phases, and we have a neutral. So this is going to be 4 for the number of wires. So far, so good. Alright, our panel that we're using here, this panel schedule is LP3. There are other panels in this project. When we get to the riser diagram, we'll see which other panels we're using. but this is the panel that we're using for this project, so this is all we're really concerned about. We don't have to worry about LP2 and LP1 in terms of filling out the this type of schedule. We just need to look at this one. So the input panel number, LP3, is what you want to put there. And I used the 300 millimeter high text for that one. It's a little bit larger. It's more of a title. The location, the room location of the panel. So the location is the actual room location. And so I'm going to make a copy of this. Where's our panel located? It's located in room number 15. So I changed that to, actually I'm going to put room 15. Let me just center this here as well. Alright, so the feeder. We look at our instructions here. Get to the instructions, just one sec. We look at the instructions. It says we're going to ignore the feeder section for now. Okay, we'll come back to that. So I just put a little placeholder of a text in there, but we're going to ignore that for now. Maybe I'll change that. So just say ignore for now. Okay, just so that everyone's clear. We will come back to that, but we have to do some calculations first before we get to that. Input the cable location. So this is where the main service for the panel comes in. It's coming in from the top. So let me grab this text here, make a copy of it. This is coming in from the top. I'll just move it over and center it here. Okay, that's where the cable location comes in. Sometimes they'll come in from the bottom, might come in from the side. This one is coming in from the top. That means that the service is coming in from the from the top of the panel. It's entering into the top. That's important so that the electrician knows which portion of the, or what part of the panel to open up to allow for the cabling to come through. Next one down, we're going to leave the A.busing for now. This is actually the size of the bus panels. We're going to leave that for now because we need to know how big to make them once we calculate everything first, but we'll do that later. And then we're going to do the mounting of the panel. We're going to put surface, which means that it's a surface mounted panel. So let's take this text here, copy it down. It's a surface mounted panel, so I'm just going to change the text here to surface. Whoops, I'm going to use uppercase. Try that again. Okay, so that's we're finished with the header of that schedule now. Now we're going to enter the circuit numbers on each side of the panel in the column labeled CIR. So if we go to the panel data here, we've got CIR. We're going to enter the circuit numbers all the way down on both sides of the panel. You notice that there's the left side and the right side. I've already started and did 1, 2, 1, 3, 5. Remember, we're using odd numbers here for this side of the panel. So what I'm going to do is I'm going to make a copy of this. I'm just going to copy it all the way down, because we're probably going to need several of them. And I'll just keep going. If I don't need this many, I can always delete them, right? But it's easier to put them in at once than it is to do it later. And I'll do the same thing on the right side of the panel. All right, and we'll adjust these arrows later as well. We'll see where those actually what we'll do with those. Okay, so now we want to just change the numbers. So I'm just going to go through here, and I'm just going to make sure that these are all odd numbers. Okay, and we'll continue some more later if we need them. So this is 2, sorry, that shouldn't be 3, that should be 2, 4, 6, 8, 10, 'Kay, and we'll add some more later. We'll change or modify later if we need to. So we've entered now the circuit numbers on the left side of the panel, or on each side of the panel. So remember, lighting uses odd and the convenience uses even. That's the right side of the panel. And then we're going to enter the location of the circuits in the column labeled location. So the example here is that for each room, we're going to be, where that circuit is found, we're going to be putting in the room number. And if we use more than one circuit per room, then we're going to be putting each room that circuit was used in. So for example, if we have a situation where luminaires, if you look at the circuit number of the luminaires, you might have circuit number 5. And circuit number 5, if you look on the plans, can be found in 2 different rooms. If that's the case, then you put each of those room numbers in that location. If you can only find that circuit in one room, then that's the only room that you need to put in that location. But we want to make sure that if somebody comes to this panel and wants to turn off one of those breakers, they know exactly which rooms will be affected by that turning off of the breaker. So that's what we want to do here, is we want to change this text location. Again, I just put a placeholder text in here. So let's do the first one, circuit number 1. I'm just going to assume that, everyone might have a different set of circuit numbers here, but if we go to what I did with the demo, I have circuit number 1 in room 6, and it's only in room 6. So if I look at room 5, I use circuit number 3 in room 5. Okay, so I'm going to come back over here to my panel, and circuit number 1 is only room, I use capital locks here, room 6. Okay, now if I look at circuit number 3, I've only used that in room number 5. So I'm going to change that to room 5. And now if I look at circuit number 5, let's just look at that right here. So circuit number 5 is this one here. Now I didn't finish this layout, but I imagine I could probably actually put some of circuit number 5 into room 10. So this is an example where we have 2 rooms. So I'm going to actually say that, yeah, we've got 12 luminaires in room number 4, and we've got, say, another, maximum of 6 in room number 10. So I'm going to divide circuit number 5 into rooms 4 and 10. Now you may have done something different, that's fine. If you planned it out a little bit differently, don't worry about it. But I'm going to, just for the purposes of filling this panel out, and I'm not going to fill out the entire panel, I think you guys get the idea. So room number 4, and room number 10. So that would be an example where, circuit number 5 spans across 2 different rooms. So you're going to do all of the locations for every circuit. So just take a look on your plan. Where did you use circuit number 7? Indicate the rooms. Where did you use circuit number 9? Indicate the rooms. You're just going to fill this panel out until you've used up all of the circuits that you actually use in your plan. And if you have any extras, just leave the numbers on there for now, because you're going to need a few spare according to the rules that we had. So don't start deleting. You'll just have to add them back in. So just leave some spares in there somewhere. Just keep moving the spares down if you need to. Okay, so that's the location of the circuits in the column labeled location. Now we're going to enter the number of luminaires used on each circuit on the left side of the panel in the column labeled LTG for lighting. So you notice that the panel is divided into 2, but you still have the ability to put lighting, receptacles, miscellaneous, circuits, miscellaneous. You still have the ability to put these 3 elements on both sides of the panel. You notice that it's repeated on both sides. Well, we're using the left side for lighting only, which means that this column for lighting is going to be filled out with the number of lights that we actually use on that circuit. And this side over here, we're going to reserve for receptacles. It's going to be filled out with the number of receptacles that we've used on each of those circuits. So the first thing we're going to do here is I'm just going to make a copy of this text because it's the closest to what I need. I'm going to come over here and put it in the lighting column. And I might as well make a copy all the way down. Okay, we're not going to need that many. So room number 6, if we swap over to room number 6, we had 18 luminaires in room number 6. That's the number that I'm going to place in that column. So this is 18. Room number 5 is also 18. I know that just from memory. Room number 4 and room number 10, I think there was, how many receptacles were in room number 10? I think there was 1, 2, 3, 4. Yeah. I think, or sorry, not receptacles, luminaires. I think there's 4. I got my, my schedule here. room number 4 had a total of, room number 10, sorry, had a total of 3. So there's 3 in there. So I have 12 plus 3, I have 15. Oops. Alright, so we have 15. So you get the idea. You want to fill out the actual number of luminaires that you used for that circuit. Now if I use that circuit in another room, I'm going to add the room and I'm going to increase the number of lighting luminaires. Okay, so that's the number of luminaires that we've used. Now we're going to do the same thing with the convenience outlets or receptacles on the right-hand side of the panel. And so let's go over to the right-hand side. Let's do the same thing over here. And if you want to work only on the left side, that's fine. I've just, I've made it so that you're kind of doing the same thing through my instructions. But if you want to mix it up, that's fine. It's up to you. Okay, so now we want to actually look at the location where we used circuit number 2. So I'm just going to, I don't know if this is correct for you or not. Again, yours might be a little bit different, but I'm going to say I used circuit number 2 in room 6 and room 5. So I used it in 2 of those rooms, and I'm going to say, and also room 4. Okay, if you run out of room, you can always change that text. You can just go room 6, 5, 4. You can do something like that. That's no problem. Because you may have used those circuits in numerous locations, especially with the offices. And if you run out of room and space there, then just shorten it up. Just say room 6, 5, 4. That's fine too. And here you're just going to put the total number of receptacles that you use. So because this is an office, I'm imagining that I'm going to be completing all of the receptacles that are allowed for an office, which is a maximum of 8. So I'm going to just place the number 8 there. And now let's just imagine for circuit number 4, just for the purposes of showing you another example, I'm going to say room 3, 9, and 2. I don't know if that's the same number you have or not. And again, those are offices, so there's going to be a total of 8 receptacles that I used for that circuit on there as well. Actually, sorry, that's probably, because I probably mixed up a little bit of the circuits, it's probably going to be 6, 5, and 4 as well. Because we need to alternate our circuits in each room, right? Okay. So that's the number of luminaires, that's the number of convenience outlets, receptacles, so we're down to step number 7. Enter the phase wattage on both the left and right side of the panel according to the guidelines in the panel schedule calculations. So if we go back to the panel schedule calculations, let me zoom in a bit on this. It says that for circuits feeding lights, we're going to enter the connected wattage in the appropriate phase. So what that's telling us is it's saying for that we actually want to check how many watts each of those lights actually are and multiply by the number of lights that we use. That's going to be the phase wattage for that circuit. So let's go back to AutoCAD here. The luminaires, the type that we used in room 6, those were the LED lights. Those are 48.2 watts. Now if you want to be sure about that, you can actually go back here. I've actually got where is it here? I've got a link to luminaire spec sheets. Here we go. I got a link to the luminaire spec sheets. It's a PDF file, and you can look up the wattage of each of those lights if you want to. You can also look in the project specs because we have that in there as well. Let me just open up the luminaire spec sheet so you can see where we're getting this information from. So this is the luminaire spec sheets. This is the type of light that we have in those rooms. And if we look down in the energy data here, or the information, input watts is 48.3 watts. That's where I'm getting that number from, so 48.3. So we go back to AutoCAD, and it's 48.3 times 18. So let me just grab my calculator here. So I have 869.4 is my answer there, 869.4. That's 48.3 watts multiplied by the number of luminaires that I had for that. Just delete that, I accidentally copied 2 text over. So this was 869.4. I'm just going to round it up to 870. I'm going to round it up to the nearest watt. Or not the nearest watt, but to the next watt up. So that's 870. Now that is on phase A. Because if you notice that position number 1, everything will be on phase A with position number 1. And that's according to the physical orientation or the physical layout of the panel. It alternates A, B, C as you go down from one row to the next. So this can only be, circuit number 1 can only be on phase A. You can't change that. Even if you wanted to, you couldn't, because physically the panel won't let you. So it has to be on phase A. So for the room number 5, it's the same value, right? Because we have the same number of luminaires and the same type of luminaires. But the only difference is now this is on phase B. Because if you look at the middle here, you notice that the dot is telling you that this row, everything on this row, even on the receptacle side, is going to be on phase B. And then lastly, we have a total of 15 luminaires on circuit number 3. So this will be a slightly different calculation. This will be 15 times 48.3. This is going to be 725, just rounding up again to the nearest watt. Or not the nearest watt, but rounding up to the watt. So that's 725 watts on phase C. Remember, this is phase C, can only be on phase C. So you get the idea. So you're going to take the total number of lights that you've used, multiply by the wattage of those lights. Now keep in mind that we do not have all 48.3 watt lights. If you're talking about the corridor or the hallway, they're 51 watts, I believe, for the compact fluorescents. And if you're talking about those metal halides that are in the workshop, those are 250 watts. So you're going to have different phase wattages all the way down, also depending on the number of actual luminaires that you used in that particular room. So keep that in mind. You're going to do the same thing over here, except the calculation's slightly different. So we have to go back to the panel schedule notes to find out how do we calculate convenience outlets. So they're a little bit different. So we're using 15 amp breakers here. We're going to calculate the phase wattage as follows. So 1440 watts divided by the maximum number per circuit times the actual number on that circuit. So we have 1440 watts divided by the maximum per circuit. So in this case, with the offices, we have a maximum of 8 per circuit, and we used 8. So what do you think the wattage is going to be there? It should be 1440, right? So let's make a copy of this. I'm going to copy it from here into the wattage, and this is on phase A. It has to be on phase A, can't be anything else, and this is going to be 1440. So again, calculation that we used there is according to the panel schedule notes. We take 1440 divided by the maximum number per circuit. So the maximum number that we can have for an office according to our specs is 8. Maximum number in a corridor is 2. Maximum number in a workshop is 6. That's going to be the number that you place in that location there, and you're going to multiply it by the actual number that you used on that circuit. So we actually used 8 on this circuit, so therefore it's 1440, because if you take 1440 divided by 8 times 8, you're at 1440. And so you're going to do the same thing all the way down. Keep in mind of your, be conscious of your phases. Okay, so make sure that you put the right number in the right column according to the phase that you see for that row. Okay, so that was step number 7, I believe. We'll go back to this here. So that was the phase wattage on both the left and the right side of the panel. You're going to use the actual wattage, and you want to make sure that you verify that according to the luminaires that I showed you there from those schedules, or from those lighting types. Now, what we're going to do is we're going to actually enter the spare circuits as per our panel schedule calculations, and the wattages of these circuits as per this panel schedule calculation. So spare circuits number 3, we're going to allow 1 spare circuit for every 5 circuits used. So, and those are going to be 500 watts for each spare circuit, and they will use 15 amps for the spare circuits no matter what side of the panel it's on. Even if it's on the left side of the panel, it's still going to be 15 amps. So you notice that there's this arrow here which tells you the breaker size, and we have 20 amps for the left side of the panel all the way down to this right here. Now, for every one of the lights that you actually use, and for every one of these rows that you complete, you're going to be using 20 amps. When you run out of circuits, you've now got every circuit accounted for, you're going to add in the spares. So let's just imagine for a second that we use 15 circuits. Then we're going to have 4 spares. Not 3, but 4. We round up. So we'll have 4 spares. So I'm going to get rid of one of these. We'll have 4 spares, and each of those spares is going to use a 15 amp breaker. Because they are spares, they're basically just for expansion. We don't need to worry about them being on 20 amp circuits. I mean, it's likely that they may actually never even get used. And then we're just going to move the arrow. Oops, that one didn't work very well. We're just going to move the arrow up to the location where we use the last spare. So now this is telling us that we use 15 amp circuits for every single one of these. Rather than putting 15 amps in 4 times, we just use an arrow to indicate that. Okay? You can, if you want to, you can put 20 amps in every single column, that's fine, in every single row. And then on the right side, we're going to use 15 amps. And because they're all 15 amps, all we need to do is take our spare, and depending on the number of calculations that or the number of circuits that we use, we're going to add in a certain number of spares again, 1 for every 5 circuits used, round up. So if we use, again, 12 circuits here, we're going to put in 3 spares. Now I don't know your actual number. Everyone's layout might be a little bit different depending on how you split up the circuits. You're going to have to calculate that once you complete the table in terms of all the rooms and the circuits that you've actually used. And we're going to enter 500 watts for each spare circuit according to whichever phase that it's on. So for this first line here, this is on phase A. I'm going to enter 500 watts in the column for phase A. Okay. The next one is on phase B. So I enter 500 for phase B, and it just alternates. It goes ABC, ABC. So that's what you're going to do there. You're just going to enter 500 watts for both sides. So that'll be for this side of the panel, and this will also be for this side of the panel, keeping in mind which phase that this is actually on. That's on phase A. ABC. So that's the number 8. Now we're in number 9. We're going to add up the totals, the phase totals from each of the columns and the total wattage in the appropriate location at the bottom under the table totals. So if we look at the bottom of our panel, we have a column here, or a row, that says totals. So what we're going to do is we're going to add up everything in phase A, all the wattages we have in phase A, and we're going to put a total at the bottom for just phase A. So I'm just going to, I'm just going to estimate that this is, 8,000 watts. Okay, I don't know if that's the actual number or not. I'm just going to estimate. And then we're going to go through and we're going to do the same thing for phase B. We're going to add up all the totals for phase B and all the totals for phase C. So you'll have 3 numbers at the bottom. They won't necessarily be the same. So they could be different depending on what you've got connected in each phase. The next step is if you notice that one phase is more heavily loaded, more than 10% from any other phase, then you move one of the spare circuits from one phase to another in order to balance those phases more evenly. So these spare circuits don't have to be connected directly to the end of your list. They can be further down. It depends on which phase you want. So you're going to use the spares as an opportunity to balance out the phases. So for example, if I had one of these phases at 8,000, I had another one at 8,800, and I had another one at 9,000. Okay, let's just imagine that's how it went. This here is 10% more than that phase. So phase C is 10% more than phase A. I have to fix that, which means I have to add more into phase A to accommodate for, the 10% difference. So what I'm going to do is I'm going to move this spare here. I'll move it down, I'll move this spare, for example, from phase C into phase A. So I'm just going to move the location. I'm going to grab this, I'm going to move it, and I'm going to move it from phase C into phase A. So I want to try and get it down to here. And I'm going to move this text here now over, and I'll increase this up to 8,500. And I'll decrease this down to 8,500. Get the idea? Now they're within 10% of each other. Okay, so that it's okay to have spaces in your panel like that. Ideally, you don't want to, but it's okay to have that. And so then, keep in mind that if I do that, I'm also going to have to copy down my breaker size so that we know, the electrician knows exactly what size to make that breaker. Okay, and it's a spare, so they won't have any numbers. They don't actually have a circuit number. So you want to try and keep these all within 10% of one another. So if you look at each one, it should be within 10% of the other one. Okay, that's balancing your phases. Now once you have those totals for both sides of the panel, you're going to add up A from the left side of the panel to A from the right side of the panel, and you're going to put the phase A total down here in this section here. So I'm going to just make a copy of this here. And so let's say, oh, put my snap on there. If you've balanced both sides, then you shouldn't have any issues with having to balance here, but you do want to check that, make sure this is within 10% balance as well. So we're just going to put in the phase totals for each one of these. So this might be, 17,100. This might be 17,500. And this might be again 17,100. Okay, I'm just estimating what it's going to be. I don't know exactly what it will end up being for your situation. Okay, and so that's using the sorry, which step is that? That's step number 11 into the panel total. Or sorry, that's step number 10. Input the wattages of each three phases. Step number 11 is inputting the panel total. So now we're going to actually add up all three phases, and we're going to put the panel total. So add up 17,000 three times. That's going to be our panel total. Okay, you guys know what I mean by that. And then this value here is going to be divided by 1,000. So you're going to take this panel total, divide it by 1,000, and input the number in here. So we've got 17,000. Let's just do that here. 17,100. So I have a panel total of 51,500. $51,700. In this field down here, you're going to divide it by 1,000 because it's in kilowatts now. So we're going to say 51.7 kilowatts. Okay, so take this value, divide it by 1,000. That gives you your kilowatts. Okay. Next step is we're going to enter the phase voltage in the voltage of each phase in the at field. Okay, so this is kind of like 51.7 kilowatts at 100. This is going to be the phase voltage. So this is 120 volts. Okay, not 208 volts. That's the panel voltage, but the phase voltage, that's the voltage of each phase. Is 120. Okay, now we're going to use another calculation again from those panel schedule calculations for the total amperage used by the three-phase panel. So we flip back over to here, determine the panel current rating. That's the amount of amperage that's used by the panel. We're going to take the heaviest loaded phase wattage and divide it by 120, and then add 20% for expansion. So the heaviest loaded phase wattage. So let's go back to AutoCAD and figure out which one that was. Heaviest loaded phase wattage. So if we look at all our three phases here, the heaviest loaded one is phase B. So we're going to take phase B and we're going to divide that. Go back to our calculations here, sorry. Come on. We're going to divide that by 120 and multiply by 1.2. So 120%, basically, 1.2 is what we're doing. So we're going to take 17,500 divided by 120, multiplied by 1.2, and that gives us 175, and that doesn't seem right. Hang on. Yeah, it is correct. I mean, your values won't be the same as this one. I'm just using numbers. Your values for the phase wattage totals will be a lot less than this. Okay, three phases at, and this will be 175. In this example, again, yours will not be this high. Okay. You should actually have a number that's less than 100. And then you're going to determine a breaker size according to that. So when we go to the schedule here, we go to the available panel size, it comes in increments of 60, 100, 150, 225. In our example, this will not be your example, but in our example, we're at 175 amps. We need to size our breaker larger than 175. So 150 won't cut it. We would have to go to 225 amps. So in this location here, we'd be putting 225 amp circuit breaker. Again, like I said, your number will not be this high, so if you get 175, you've done something wrong. This is just for the purposes of this example. Okay, so 225 is going to be your circuit breaker size, larger than the available panel size. So step number 16 is the last step. Now that we know the size of the panel that we require, so if we go back to AutoCAD, we know that we need a panel that has a capability of 225 amps. That's the circuit breaker size, and we need 175 amps between the three phases. We're going to come back up here and we're going to size the feeder. Now the way that we do that is we're going to calculate the size of the conductor required for the feeder for this. So 100 amps is the minimum ampacity the conductor required. Now that's an example where if it was 100 amps that we would be using in this situation here. And in this case we have 175 amps. Those three phases are going to use 175 amps maximum. So we need to size the feeder at 175 amps. So we're going to do that using the information sheets that I gave to you guys for doing your motor schedule calculations. So that's going to be the from table number 2, I believe. Is it table number 2? Just let me check. Yeah, table number 2. So if we look at table number 2, table number 2 gives us the ampacity of the conductor. So we're going to find a conductor that has the ability to run 175 amps on it safely. And if I look down on table number 2, I see that we can use a 2-watt. So this is going to be a 2-watt feeder. So the feeder size is going to be American wire gauge, 2-watt. That's the 2 zeros like that. And that's all we need. So that's the feeder size. And that also happens to be, we'll just double check here, the busing information, which will be the same as the circuit breaker size. So the circuit breaker here we have at 225 amps. That's the main circuit breaker. We need to make sure that we have a busing amp of 225. So I'm just going to make a copy of this and paste it up here. Come on. Alright, so now we've finished panel number 3. And we'll be using these values, the AWG 2-watt, we'll be using that over in the main distribution panel schedule, but we'll get to that in a bit.